I said that that's not all. So quiver plots aren't always the best choice for representing what a flow is doing. Actually, probably the most common way to describe what a flow is doing, especially in 2 dimensions and the kind of things that we're going to work with in this class, is usually streamlines. So what is a streamline? So, but the definition of a streamline feels a little bit complicated, but you'll see it actually is pretty easy. So the definition is that a streamline is a curve whose tangent at point r is parallel to the velocity vector at r. That basically means that like the slope of the line always goes in the direction of the velocity. And I'll show you that this leads to some really good properties as we go. And some, you know, I think it'll be a pretty intuitive way of describing things. So what does that actually mean? So that means that like if I were to look at the slope like dy dx of any one of, so actually when I look at this plot, let me pull up my arrow. Okay, so like if I pull up this is one streamline right here. So like you can imagine that this basically is the equation for a curve y versus x. So this is one streamline of the flow, and in this streamline or stream plot, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 different streamlines are shown here on one plot. Okay, so the definition of the streamline up here mathematically basically tells you that basically the slope of that line is locally equal to, you know, the slope of the vector, the velocity vector that you would see. So the rise over run is equal to the rise over run of the velocity vector. That defines the shape of the curve. And you'll see that that definition makes it actually pretty easy to analytically often solve for what the equation y versus x is. So I'll do that. In a little bit, I'll show you some examples of how to do that because it's such a common thing to do. So the only thing that I would point out I'll show you some other ways of graphically describing, you know, flows. And the thing that is really kind of interesting about streamlines is that streamlines are at a particular instant of time. So, you know, whether a line is, you know, parallel to the velocity vector, you know, if the velocity vector is changing with time, that means that the streamline is changing with time. So at a particular instant of time, it's given by this equation, but what the streamlines look like, you know, over time will change. So again, there are commands to generate streamlines in the 2 languages that are most commonly used by engineers. So in MATLAB, that is called Streamline, and in Python, it's buried inside the matplotlib pyplot thing, and it's called, I think, streamplot. So that's fine. Those will generate perfectly nice graphs, but actually we probably won't need them in this class, but I may ask you to do an example of a more complicated flow computationally. In this class, we'll probably just do any of this by hand. As I'll show you, like solving this equation for most common flow patterns is actually not too hard. So we'll just do that by hand.